So we will discuss about these tools, and after that we will perform the mini project. So please, anyone confirm my screen is visible or not?
Yes, yes.
Yes, it's visible.
Okay. So we have covered these details already up to just a minute. AWS Git, I think was yeah, job preparation. So today we will discuss about little bit about version control system and about pipeline creating tool, that is Jenkins, and about Docker. So that if we will go so that we if we are going to perform a mini project, then all these tools will be used. Okay, so firstly, what is version control system? So version control system is a tool that is used to maintain your code versions. It's just similar like if you can say we have a iPhone 13 now, but they are maintaining their version from iPhone 3, iPhone 4, iPhone 6, and all these. These are the versions. Similarly, in the IT sector, there are version of codes because everyone starts from the fresh code, but multiple developers are there who are working on the same code. Okay, so they are doing some changes in the code to develop that application. So everyone means doing changes and to maintain that changes, and to know about those changes, we are using version control system in DevOps line. So like there are two developers. One is write some code today, and he push to the central repository, and after that next day the second developer come and work on the that code. Before working on that code, he pulled that previous code which was done by developer A, and after that he do some changes in that code, and again push to the central repository. So there will be a two version. First is created by developer A, then that file will be saved. Next, when developer B work on that file, again he push to the central repo. Then there will be next version of that file, V2 we can say, of that code. Okay, so you will find both the files, V1 as well as V2. They will means it will not append the files on each other. Okay, in this way the version control system maintain the version of the codes. Similarly, if I just draw a painting, uh, suppose developer one has done some work here, and it just push that code into the central repo. Okay, so now this is, I can say, developer one, dev A. Okay, now next day developer B come to the office and pull that code from the repo. Okay, again he will just pull that code from the repo and do some changes on the existing code, and again push that code to the central repo. So on the next day, developer A will able to see both the files from the version A and the version B, and he can also see the changes. What means the developer B made changes in the existing code. So this is the version control system. So currently means there are two types of version control system. One is your CVCS and second is DVCS. What is CVCS? DVCS. CVCS is your centralized version control system. DVCS is your distributed version control system. So what is CVCS? Means CVCS is your client server model. Okay, so if I explain about that, uh, this is your server. There are two clients, or you can say two developers. So both the developer will pull the code from the central repo and again do their work and again push back to the central repo. So this will be your central repo, we can say server, and this is your client or developer machines, dev machines. Okay. So similarly, this is your client slash dev machine. So developer work on these machines and push them back to the your server. Server will be your central repo. Okay, on central repo you just create some branches respect to the task and push back to the server again. This is all about the centralized server because everything is stored on a central server, on a centralized server. This is common for all the developers. Okay, so this is basically the centralized. But in the distributed version control system, there will be two repos. One is your local repo, and second will be your centralized repo. So concept is the same, just like centralized version control system. But you have two repos. One is locally on your system, and second will be your on your centralized server. So that will be just like this. This is your central server. This is your machine 1, machine 2, and there will be a repo. This is your local repo. Okay, so what happens once you do anything, means any changes on the from developer A or developer B. So whatever you will do, you have to commit those changes. Okay. So just a minute, let me draw the complete diagram so that you will easily get there. Now, in the centralized servers, there is no mediator repo. Only you have to just do your changes or write the code and directly commit to the centralized server. But in distributed server, once you commit, it will be saved on your local repo. Okay, and after the means saving to the local repo by commit command, you have to push your code by the push command to your centralized servers. Now you have your code on two places, one at centralized server, second is in your local repo. If you are going to work again on the means next day, then you have to again run a command to your centralized server and push back to the local repo. So this is basically the centralized version control system. Linux RHEL OS and CentOS OS, ONth OS. Means we are deploying complete OS on a single VM, and it will take your time and your memory, because if you run Windows 10, then they have mentioned that at least 4 GB RAM is required to run this window, and so that you can means work effectively and efficiently on this operating system. So they are utilizing your means 4 GB RAM, right? But you have only space of 2 GB RAM. Then how you will install that? From there, they just bring a concept of containerization, in which you will just install a single OS on your server. There is your VM. Okay, I can say this is your complete laptop, and you have RHEL OS on this. This is your actual OS working on this laptop. So now we have OS over there. So OS is containing some specific RAM, like in the Linux, it's means you can means enable it to up to 2 GB RAM and minimum around 20 GB hard disk. So in which your OS is working. OS RHEL is working. Okay. Sorry. So now you have means I can say you have around 16 GB RAM. So out of this, now you have 14 GB RAM and 1.5 or approx 1 TB hard disk. So now you cannot means install another OS on this without any hypervisor or VMware. If you are installing any, also contains some memory and some hard disk. So suppose we have installed a VMware here. VMware. So VMware is using minimum 1 GB of RAM and 5 GB of your hard disk for their means installing the base files. So you have installed VMware on this OS. Now you want 4 virtual machines. That is first, that is second, that is third, and that is fourth. Okay. So first VM is your VM1, that is Windows. And second is your CentOS. Third is your Ubuntu. And fourth is your again Windows.
Linux.
Okay. Linux is means these are the flavors of Linux. So I am just mentioning Windows 10 here, and Windows is here that you can consider as Windows 7. Okay. That will differentiate each VM. Say this will be a VM2, this will be a VM3, and this will be a VM4. Okay. So now here I said we have only now how much RAM we have? 13 GB. Okay. So this RAM is containing 4 GB. This machine, and this is also using 4 GB RAM. 448. Okay. Now if you are again means putting a CentOS image, that will use 2 GB RAM. As I have mentioned, Linux version minimum requirement is 2 GB RAM to work effectively on your machine, and here is 2 GB RAM. So we have left only 1 GB RAM, right? And we have installed a complete OS on this, right? If I want to create a window machine again, then I am unable to create that machine due to insufficient memory. Okay. This is the concept of virtualization, where you are using a OS over which you have deployed a VMware, and on the VMware you have created some virtual machines. Here we have we are not using our resources effectively. We have wasted multiple means we have wasted multiple things like even we have wasted our CPU, we have wasted our RAM and hard disk. All the things we are wasting here, right? And even we cannot create the next virtual machine over here due to lack of the RAM or CPUs. So to overcome these problems, the method is called containerization. Okay, so what is the containerization? We will keep the same example. Okay, here we have our RHEL OS with 2 GB RAM and 20 GB hard disk. Now we have around 14 GB RAM and 1 TB hard disk. Now here a concept come containerization. What containerization actually do for running? If I taking an example of Docker, so you have to install a small application called Docker engine. Okay, so Docker engine you will install here. And in the Docker engine, it will consume hardly your 200 MB of RAM. Sorry, 200 MB of RAM and around 1 GB of your hard disk. Okay, so now we have approximately 13.8 GB RAM and approximately similar, you can say 99 GB of, sorry, it's 1999. Okay, means approximately 1 TB same, because we have reduced only 1 GB, right? So Docker engine will enable you to create different applications. You will have some base images which are very light. It approximately, if I talk about any OS, that will be approximate 5 to 8 GB RAM, 5 to 8 GB size. Like if you go for RHEL, it's around 7.3 GB of OS size, and for the CentOS it's around 10 GB. For Ubuntu is also there some kind of around 8 to 9 GB in the Windows as well. Okay, so but in the Docker Hub there are small light images, approximately 300 MB image, 400 MB image, 500 MB image maximum. You will not see around the image above the 1 GB. Okay, so you want to install application Windows, multiple Windows or OS. I have created I'm just drawing. I have created five container will be run. First will be your window. Second will be your CentOS. Third will be your Win 10. Fourth will be you are running like any database, Postgres. And next will be your Ubuntu. Okay. Now these are very light images, as I told you, maximum 300 or 400 MB, and they will just use around 100 200 MB RAM only. Okay, the concept if I will tell you, then it will take too much time. So I'm just telling you that these images are approximate, like this is 350 MB and will consume only 200 MB RAM, and this image of 375 MB, this image is of 450 MB. So from the complete OS, these images are very light, so they will not consume your hard disk. And if you will run these light images, even they will not consume your so much RAM. They will consume only 200 300 MB RAM and milli CPUs, not the complete CPU. Complete core of the CPU. They will use your CPU in the millis. Okay. So if you want to create 5 more containers, you can easily create, because if I calculate around, I'm taking 300 as the average RAM for each container, then there will be approximate only 1500, means 1.5 GB, right? Now you have 13.8 GB. If you reduce that from 1.5 is around your 12.3, right? 12.3 RAM, still you have free RAM. So you can imagine how much container you can run over a single machine using a single OS. And each machine will work effectively just like your real OS. Okay, there will be means no limitations, like you cannot create this, or you cannot create any of software, you cannot install any software, you cannot create any file. All the tasks you can perform in these small images. Okay, so understand this is the containerization. You are means dividing your hardware into multiple containers using Docker engine, and these are also created virtually. Okay, I have just connected with my hotspot, mobile hotspot, and you can understand how much network speed is there on your hotspot. Now, fourth is your working directory. Means it's making your where HTTP, where www and HTML as a working directory. So whenever you will log in into your container, you will find yourself in the HTML directory. Okay. Here we have exposed port 80 because our web server mostly use port 80, but you can means expose any port. There is no issue. You can customize your port numbers inside or outside. Now they are running a command which I have mentioned. This is the command. Okay, this is finished. Let's see. There are two images. First is your CentOS, that is base image. Second is your test image, which I have created. Now you can see I have installed HTTPD. Now base image is only 204 MB, right? If you will use OS, that will be around will take around 8 to 10 GB of size, but it is only having 204 MB size. So it is very light as compared to complete OS. Now it's 402 as you have installed a web server here, right? So next thing what we will see, as I see, we can see Docker file, what is written in the Docker file from here. Sorry. So we have written, this is a new demo bed. Till now, I have not mentioned any command for the container, means to run the container. I have just mentioned only, and you can, as I told you, that you can see each step from outside as well. You don't need to go to the console output. You can see each and every step from here. Okay. So next will be your, let's configure and let's run a command for creating a container. Next will be your Docker run -d -name web server, and the image name you have created. Before that, you have to expose a port 80:80, and after that the image name you have created here. Okay. And just you have created Docker run -name will be web server, port will be this, image will be this. And now again you have to click build now. That will create means run your pipeline again. So let's see. Now as we have already created these steps, so it is not going to perform these steps again. It will perform only the last step. Docker run -d web server -p, and this is the command we have run. So now it is creating a container. Okay. So as I already tell you that there was no container previously. Now they are just running that command. Once it is completed, we will see.
Ajay, quick question. So currently all softwares are on same server like Docker, Jenkins, Git.
No. Git is means Git. I have login directly to my means GitHub account.
Okay.
You can use any software. Means you have to install some plugins to use those softwares. Sorry, those servers. If you are installing those software into different machines, then you have to use SSH agent like plugins to access those software and run your pipeline. Means if you want to deploy your Docker container to different server, so you must have your SSH plugin. Okay, so that it will Jenkins will able to access that server and run those commands which you have mentioned in your script.
Okay.
Understand?
Yeah, fine. And Jenkins is a separate server and Docker is a separate server, you mean to say? I mean, whatever you have running.
means Jenkins is your server which is worked on plugins. It's a plugin based servers. So for each software, there means for each, not I'm saying each, for many softwares, you will find the plugins. Okay, if you want to connect to the like if I talk about the Sonar Cube, then you can install the Sonar Cube on different server, but you have to install a plugin of Sonar Cube in Jenkins so that it will able to connect via that plugin. Okay, let's see here.
Okay, fine. Thank
Docker
you.
PS. So now our web server is running here, right? And we have exposed it on port 80. Let's see here. Let me means copy this. I already means run this in front of you. Now this is the demo session for new batch. Now we have run a small mini project that how you can deploy your web server via Jenkins using Git and Docker. So I think you have understand all the things. If you have any query, just let me know right now. And if someone means just give me, let me go to the chat section. Is there any query? No. Or a visible no, mostly used operating system in real time.
Hello.
Operating
Hello.
system.
I have a question.
Yes.
Hello.
Yes.
While
Yeah, sorry.
hello. Am I audible?
Yeah, you are audible.
Okay. When we are going to company on, inside, we are creating Docker files, or we need to we have any existing files. What we are?
No, you have to create the Docker file.
Okay.
And you have to means you will means you can expect only two things from the developer. One is your code, second is the dependencies. Okay, from the
Okay.
developer side, you will just they will tell you that this is my code, and you have to
Okay.
build it via Maven, via Ant, via Gradle. Okay,
Okay.
and after that they will tell you on which by which base image it will run. Like if it's a Java application, so
Okay.
definitely it will run via Java container. Okay,
Hmm.
and if it
Hmm.
is a web application, then definitely it will run via your uh, Tomcat server, right?
Hmm.
So they
Yes.
will just tell you the dependency. Okay.
Okay.
After
Okay.
that, you have to decide how you will means there is a ongoing projects and there is new projects as well. If you are
Okay.
asking for ongoing project prospect, then they will just tell you that the please create a new branch for me. I'm writing this
Okay.
code. Okay. So
Okay.
then you
Okay.
have to create a new branch for that person or developer. He will
Hmm.
use that branch and push the code written by him to the Docker
Okay.
Hub, sorry, GitHub, and
Hmm.
after that, all is yours. You have to decide how to use that complete Git, Jenkins, or Docker, and even you have to automate that. Means once the developer push the code to the branch, it automatically trigger to the Jenkins
Okay.
and
Hmm.
automatically build will start, automatically deployment will happen, and next step automatically you will receive the successful or failure mail that your pipeline has been failed on this stage. Okay,
Okay.
so
Okay.
these kind of scenario you have to do.
Okay. Can you tell me how to create a Docker file?
Yeah,
How
means
how to?
that's why I said means it's a mini project. I have just give you a small introduction about this.
Sure, sure.
So
Okay.
creating a Docker file, first you have to understand all these things, basic commands,
Okay.
right?
Yeah, it's a run working work directory. So other commands used in Docker file. Could you please explain clearly step by step? how to create a Docker file.
Yeah, Sandeep is asking how is the work with containers in real time. So Sandeep, for to work with the containers, there are two prospects. One is as I have shown for deployment prospect. Second is for your testing prospect. Like they have given you any new tool or application. They said that please deploy this application and test the feature of this application, right? So application infra is also your part. So you can create a container with the base image as mentioned in the application and deploy that application in that container, right? It will means reduce your time or and effort. Now you can explore the feature of that application and you can remove that container. But if you are going to create a complete virtual machine, that it will take lots of time, because you know how to install the OS, and OS always take up to half an hour or 1 hour to take installation, and it will also consume your RAM and hard disk memory. Okay, and for that you need at least one virtualization software in your laptop or one virtual machine on your server. Okay, so this is the real time, means you have to use the containers in your pipeline for DevOps prospect, and even you have to use your means containers. There are many things like I have mentioned in the syllabus. Docker Swarm is there, so you can use the orchestration tool Docker Swarm, and you can deploy your Jenkins on the containers, and those containers automatically means increase or decrease by, means if any node fail, then automatically they will shift their running containers to the second node. So you will create a cluster for Docker Swarm, and you will able to means do high availability for your containers and applications. Okay. Now next is your R Satish. Container image both will utilize the system resource. Depends on server resources. We can use the image and containers, right? Yeah. So Satish, this is the small mini project. But in the real time, what will you will do? You will build an image, push to the Docker Hub, right? And once you push to the Docker Hub, you will delete that image from the local system. Okay, and from the deployment server, you will fetch that image from the Docker Hub and run the container. And after that, you can again delete that image from your deployment server, because it is already saved in your Docker Hub. Anytime you can access that image from Docker Hub. So you need not to save every image on your deployment or your Jenkins server. Everything will be saved on Docker Hub. Is it clear, Satish? Yeah, Mr. R. Okay. And any more questions? So I think we are running out of time. It's 9:12, and the session was from 8 to 9. So if you don't have any questions, then we can stop the meeting and we can continue with our work.
Hi all, this is Monia. Has the session been rescheduled to 8 p.m. now, or?
Okay, you are asking for the free session,
Yeah,
right?
we used to have the DevOps discussion sessions till yesterday.
Yeah, that is means no, that session is from 9 to 10:30. Okay, this is the demo session. Who are freshers or want to join
I
the
got it.
demo?
This is that training session. I think I joined first day. So that
Right.
9 p.m. session will start
Right.
now, right?
Right,
Okay.
right. So you can join the 19.
Okay, yeah. Thank you.
Okay, so I think we can disconnect now. How to automate deployment job with Jenkins. So Sandeep, these will be means these I will teach you during the classes, because you are means asking for automation, firstly you have to understand the pipelines, how to create the pipelines, how you will understand the pipelines, right? And how to, firstly you have to understand the Git, then you have to understand the Jenkins and all the things. After that, I can elaborate you how to automate the pipeline.
Okay, thank you very much.
Can you send me the Git repo link so that we can practice?
Git repo link means I think yeah, no issue. Means I will share the repo link. Okay.
Sure. Okay.
Firstly, I have to make it uh, public, right? It's a private, so no
Okay.
issue. I will make it public and I will share. Okay, no issue. Ram will share in the group. Okay.
Okay. Okay. Thank you.
Is there any question?